Hey guys, so for this assignment, just a quick tutorial on how to write the equations. Right here, it says for numbers 3 and 4, use DESMOS to write the equation. That's because they're not perfectly doing the exact same thing from one output to the next. Meaning, like here, it's every time it's times 2. 5 times 2 is 10. Times 2 is 20, times 2 is 40. But right here it goes from 3 to 6, so these are no longer consecutive, so multiplying by 20 isn't going to give you that next output because it's no longer consecutive. But either way, this one also turns out to be perfectly doing the exact same thing. Divide by 3, divide by 3, divide by 3. It's dividing by 3 every time, so the ones where I can easily see exactly what is happening, I could do by hand. But these down here, even with a calculator, it's not necessarily doing the exact same thing to go from one output to the next. However, once graphed, it kind of looks like an exponential relationship. So since it's not perfectly multiplying by 2 or perfectly multiplying by, like this one is dividing by 3, so it's multiplying by 1/3 every time. These ones aren't doing that. Even this one, it's not necessarily multiplying by the exact same thing, or at least it's not something that I could think of mental math. So anyhow, when that's the case, you could use DESMOS and do an exponential regression and figure out what the equation is. So I just want to kind of show you what steps 3 and 4 are asking you to do. So if you guys go to DESMOS.com, this is where you'll get to this page, and the very top thing, the graphing calculator, that's what you want to use. So again, if you have an exponential set of data, and this one, this assignment told you it was exponential, you could, and you're not sure what it's doing, you could go to DESMOS.com, click at this very top thing, graphing calculator. Once you click into there, what you're gonna do is click on this plus sign and the table, and then you're gonna fill in all the data that was all that information, all those ordered pairs. So the data was 0, 2, 4, 6. These are just the inputs, of course. 8, 10, 12, and 16. The associated outputs were 25, 36, 52, 68, 85, 104, 142, and 260. Again, I'm not exactly sure what the equation would be, right? So I'm using DESMOS for that. And here you can see the points. DESMOS, if I keep zooming out, it'll show me all the points. However, it doesn't really show me them looking very exponential. So what I want to do is I want to go to this little wrench here and adjust, like my x-axis goes from 0 to 16. I mean, it does go negative eventually, so anyhow, again, if I go into the wrench, you can see the x-axis here. I really only want the x-axis to show me maybe from negative 20 to positive 20, or yeah, it only goes to 16, so I'm asking the x-axis to show me the graph from negative 20 to 20. The y-axis goes from 25 to 260, so maybe I'll just, kind of want to make sure I see everything, so I'll tell it to go to negative 1. As you can see, it doesn't go to negative 1 here, so I'm just going to put negative 1, and it does go all the way to 260, so I'm going to put 300 there. And so anyhow, now that I've adjusted this, I can go back out here, and you see how it actually looks. It actually looks a little more exponential there. In fact, look at where 260 is. 260 is up here, and so adjusting the x and y axis does allow you to see it looking a bit more exponential. Our data stops right there though, but I hope you would agree that it is definitely not linear, and it does start to do what an exponential curve should do. which is it falls very quickly. Remember, they always fall or rise. Well, actually, I guess it depends on how you think about it, but I guess technically this one's rising because it's going as you move to the right. Either way, it's going to be flat on this side. You can see it is flattening out, and it rises very quickly on the right. So, so it is exponential, and then you want to have an equation, okay? So go to your next spot or next function, or whatever you want to call it here in DESMOS, and here's what you have to do. Since your inputs here are called x1 and y1, and you're going to use, again, I'm just going through those steps that are in that assignment. You're going to use the equation y equals a times b to the x, y equals a times b to the x power, and this won't give you an equation yet, though. You actually have to call y1, just the way your inputs are under y1, and you actually have to call x x1, and it can't be equals. It has to be that little squiggly approximately, because it is giving you an approximate equation for your data, for your information. So there's the squiggly thing. That's got to be y1, and this has to be x1. And once you get those things in correctly, right, y1 is approximately equal to a times b to the x1 power. DESMOS now knows to write you an exponential equation that matches the data, or at least matches the data fairly closely. So anyhow, you can see the curve. It does go fairly well through the points, but it's not perfect. Like, this gray point is on the curve, and underneath it is a green point that's not exactly perfectly underneath, or even these green points. You can see they're not perfectly on the line, like the line or the curve isn't going right through the center, but remember, it's fitting the exponential curve to the data as best as possible. So if we scroll down, we can see what a and b are, and then we'd be able to write our equation. Y equals a times b to the x power. So we would write y equals 26.8418 times 1.15179 to the x power. And what we would have is a pretty good equation for modeling the data in the assignment, right? The number of time in hours, and then the number of organisms. So I hope this helps. Definitely use it for any kind of exponential regression where you're not able to do it so easily by hand.